Hi everyone, how are you doing? So today's lab you're going to be testing some evolution ideas that we've talked about in the lecture. Now we have a single population of prey here on this table. We have prey that are big, we have prey that are small, we have prey that are kind of medium sized, but all of these represent individuals in the same population. And so they're all going to be, we'll call them rabbits. So this will be a big rabbit. This would be a small rabbit. And these would be medium-sized rabbits. So we counted these individual piles of 100, just as your lab manual dictates. Now we're going to mix everything together. Make sure our population is nice and evenly mixed. It's really too bad you guys aren't able to do this lab. It's a fun one. Lots of counting. All right, let's make sure. You don't want to make sure that anyone's prey selection is biased. Now the whole point of this lab is that the two predators, when they start feeding using their forks, they are just going to be grabbing what they can. They're not supposed to be aiming for any of the different seeds. So they shouldn't be paying attention to color or size. They should just be trying to pick up what they can. Now you flatten it all out so it's one even layer, but I would say these things look more or less mixed up. All right, so now we'll introduce our two predators. So put your stuff on the table. So this represents, the cup represents their stomach, and the fork represents their mouth part. So this is what they use to actually collect the food, and then they will deposit it in their cup once they're done collecting. Now I will start a 10-second timer, and just so we're all on the same page, we have exactly 400 seeds here, and that's important, okay? Because we're going to need to make sure that we restore 400 after each feeding trial, and we'll do 6 feeding trials. And after each feeding trial, we'll report the number eaten and the number survived. All right. So for 10 seconds, our predators will be active and they'll be feeding, after which we'll tally up what was taken and we'll put back, or we'll replenish what needs to be. Okay. Before we start, you also need to come up with a hypothesis. How do you think the different sizes of prey affect their susceptibility or vulnerability to predation? Like, does being big, does that make it easier to be preyed on, or does being small make it easier to be preyed on? Based on your understanding of what a plastic fork looks like and these different size seeds, you're going to need to come up with a hypothesis and a prediction. If you need any help, you can reach out to me and I can help you out. All right, so we'll go ahead and get the 10-second timer going. And we'll let our two predators get to work here. All right. We're starting I'm just putting in our timer of 10 seconds for our first feeding trial. All right, so ready, set, go. Okay, stop. All right, so now we need to make sure that this pile stays separate from what we have in our prey's stomach. So our prey, we're gonna put into a pile over here. Yep, go ahead and dump the prey out. Now we need to count how many of these got eaten. So why don't you guys do that? Why don't Bree, you take the big ones and the brown ones. Brooke, you take the green and the yellows. Okay, and so put them in their own little piles, and we need to figure out how many of each were eaten. Okay, so we just finished our first feeding frenzy, and these are the seeds that were eaten. So we're going to go ahead and get a report on the numbers of those, and I will fill them in on this number eaten column right here. All right, how many white seeds were eaten?
22.
22. How many pinto?
21.
21. How many pea?
9.
9. How many corn?
27.
27. Okay, so now And you're always more than welcome to reference the example we have on the first page where it shows you the math and how everything works out. But I'll work through on our first example here that we have, that we collected for our data. So the next thing you do is you get survivors. Now all you need to do is just follow the math that's laid out. So 100 minus 22 equals 78. 100 minus 21 equals 79. 100 minus 9 is 91. 100 minus 27 is 73. Now before you go any further, you need to sum this column. Let me get out my fancy calculator here. So we have 78 plus 79 plus 91 plus 73. And so this number will change every round because not the same amount of prey will get eaten. So 321. The next column we need to fill in is the proportion surviving. So we need to figure out the proportion. Now the proportion surviving is going to be the number of survivors divided by the total number of survivors. So for our first one, for the white beans, we're going to take 78, we're going to divide that by 321. That's going to give us 0.24, and I'm just going to round to 2 decimal places. So 0.24. Now let's do 79 divided by 321, which is this one divided by the total, and we get 0.246, but because it's 0.246, that 6 is going to push that 4 into a 5. So 0.25. Our next one is going to be 91 divided by 321. We have 0.28. And the last one is going to be 73 divided by 321. Whoop. Try it again. And we have 0.23 because that 7 will push that 2 into a 3. It's above 5. 0.23. Now you want to check your proportions up to this point. They should be coming in to equal 1 or slightly above or slightly below it. And by slight, I mean like 0.1. So 0.24 plus 0.25 plus 0.28 plus 0.23. Oh, we lucked out. This equals 1 exactly. It's okay if your answer is 1.01 or 0.99. It just has to be right close to 1. All right, so we're going to clear our calculator. Now, to find our adjusted population, we need to multiply our proportion of survivors by our total population size, which is 400, the same 400 that we started this experiment with. So we take 0.24, multiply by 400, and that equals 96. Then we take 0.25, multiply by 400, 100, 0.28, oh, let's clear that out, 0.28 times 400 is 112, and 0.23 times 400 is 92. And then you need to verify that all these numbers sum to 400. So we'll try that. 96 plus 100 plus 112 plus 92. It does equal 400. So now this, we're going to move this down to be our starting population for generation 2. So what happened here was you had a starting population of 100 of each trait in this population of 400. They were all adults. Some got eaten. The majority survived. They had babies, and they restored their population to the original size of 400. And so that's what this represents. This is the next starting population size. And so all we do is we write down those numbers. And we know that they already total 400 like these ones do. and then we are ready to do our next feeding frenzy. So then we will make sure that in this pile that's going to be used for feeding, that there are 96 white beans or seeds, 100 brown seeds, 112 green ones, and 92 yellow ones. Okay, so we'll go ahead and restart our population, and then we will see you for the next feeding frenzy. All right, so we have all of our dead prey from the first round, from the first generation. We have all of our seeds, which are, again, representing rabbits. Now, we talked about lynx and hares in lecture already. Think about these as dead snowshoe hares. And my lovely assistants here, think of them as the lynx that are eating the hares. So they've killed all these hares, and it's left all of these hares. So all of these ones are still alive, they survived, and now they're able to reproduce. Well, because fewer of the small hares were removed, that means that there are more, proportionally, there's more of the small hares in this population. Because of that, there's going to be more of them that are going to breed. And because of that, we're going to have more of their offspring that are going to be small. So we're going to see already that our population is going to start changing in overall size, only because it seems like a lot of the big rabbits were eaten, but very few of the small rabbits were eaten. So now we need to do a little bit more math. So we know that because there were 9 eaten here and we started with 100, we know that there are 91 small rabbits still in this population. And we understand that after reproducing, according to the proportion of available rabbits in the population, we need to have 112 rabbits in our new population for the next generation. So to get at that, all we do is we take how many rabbits we need, subtract it by how many we have, which is 91. That's going to equal 21 rabbits are what we need to add to this to get to the 112. And we will repeat that for every one of the seeds until we have a reestablished population of 400 rabbits. So we'll take a brief break until we can get all of our seeds added again, and then we'll start our second feeding frenzy. Okay, so this is, again, represents all the dead rabbits that were eaten. We went ahead and did our math, and we figured out how many new rabbits need to be added to the population to get it back to 400, and we determined, because we know that there were 321 survivors, if you take 400 and subtract 321, you get 79. So the rabbits that go into the population, it should also equal 79. So we're going to put our 79 total rabbits back into the population. And we're going to go ahead and give that a nice little mix again, just like we did before. All the rabbits start, this simulates all the rabbits running around the landscape, mixing with each other, trying to find places to hide and escape the lynx. All right, now we're going to go ahead, we're going to do our next 10-second feeding frenzy, where the 2 lynx are going to come back into the forest and they're going to hunt some rabbits. So let me get my timer going. All right, 3, 2, 1, feed. And stop. Okay, so after our second feeding frenzy, this is our new pile of dead rabbits. We still see that the big traits it looks like they're being selected for, and the smaller traits seem to be slipping by the lynx. So we're going to go ahead and record those numbers into our number eaten. So how many white hares were eaten?
18.
18. How many pinto hares?
13.
13. How many pea hares?
8.
8. And how many corn hares?
14.
14. Okay, so now I'm going to leave this table blank. We will have used this or done the first generation as an example, It's going to be up to you guys to do the rest of this math. And then I'll just go ahead and start here with the next starting population, and I will provide the number that we're eating. I'll give you that, the number that we're eating, and so on and so forth until you get to the last generation. Okay? All right, so we'll see you in the next video. So based on all of the dead rabbits from the last round, this was our population with which we had to work. We did the math and we figured out how many new hares are going to be entering the population after reproduction. And so we're going to go ahead and put all of these hares in. So now we have our 400 hares back in the population. Gonna mix it up again. All right. Okay, now I want to show you guys what we ended up with. So this is now our starting population for generation 3. 89 white rabbits, or white seeds, sorry, 101 pinto seeds, 121 peas, 89 corn. So now we're going to do our third feeding frenzy to determine how many are eaten, and we'll go from there. Let me get the timer started, and we'll let our links get ready. Are you guys ready? Okay, ready,
Yeah.
set, go. Stop. All right, so this was after our third feeding frenzy. So we're going to go ahead and write down the numbers. We'll start with Bree. How many of the white seeds were eaten?
18.
18. How many of the brown seeds?
25.
Okay. How many of the peas?
2.
And how many of the corn?
14.
Okay. So again, at this point, I'll leave it up to you to have you guys finish the math and finish the table. And we'll go ahead and do that on our end and start over for the fourth generation. So these were all our survivors from the last round. They went ahead and bred and reproduced. And these are the new incoming rabbits coming into the population. So we're going to go ahead and put them in. Get back up to, again, 400 hares in our population. And I mix them up. And give this another go. All right, we have our 400 hares. Now, again, this is our starting population for generation 4. We have 84 white, 88 pinto, 140 pea, and 88 corn. And now we're going to determine, our links are going to determine how many are eaten. So we'll get our timer. All right, ready, set, go. Stop. So after round 4, which was the last round, these were the remaining hares that could survive and can reproduce. And they had all their babies in accordance to their proportions of how many of that trait were surviving in the population. So now we are going to put the hares into the new hares into the population. Give that just a little mix. All right, now to have a close-up, we're going to be starting round 5 or generation 5 of our rabbit population. We're going to be starting with 75 white, 79 pinto, 167 pea, and 79 corn. And we're going to go ahead and get our timer set up and let our links have another stab at the population. All right, you guys ready?
Yeah.
Okay. Ready, set, go. And we're done. Okay, so we had all of our rabbits that were eaten. And for generation 5, how many white seeds were consumed?
26.
26, okay. How many pinto?
25.
25, okay. How many pea?
16.
16. And
32.
32 corn. Okay, all right. Now, so this is what we have for generation 5. I remember that I failed to provide the number eaten for the preceding generation. We had 25, 25, 8, and 24 were eaten in generation 4. All right, so sorry about that. So we've done the math. We have our population of hares. They reproduced according to their proportion in their population. And now we have the incoming hares coming into the population. We're going to go ahead and give that a little bit of a mix. Now, as you know from reading the background on this lab and doing your lab quiz, that this is a lab about evolution. And evolution, as we discussed in lecture, is simply a change over time. And the change over time that we're interested in looking at is the frequency of the phenotypes of rabbits in this population. So is there a change in the proportions of different types of hair? Is that actually happening in this population? And that's going to be the second part of this lab. But we are ready to do our last feeding trial here. Our last one. And my lovely daughters, Bree and Brooke, they have been great sports during this activity to help their dad and help you guys do a really cool evolution exercise. All right, so are the lynx ready to eat hares for the last time?
Yeah.
Okay, 3, 2, 1, go. And that's it. All right, so our lynx had their way with our hare population one last time. These were all of the hares that perished, got eaten by lynx, and we're going to go ahead and get those numbers and we'll record them in our column here on our generation 6 table. So how many white were taken?
20.
How many pinto?
27.
How many pea?
19.
And how many corn?
20.
All right, so that will give you the last set of numbers that you need to finish your calculations on your tables. What you need to do after that is we provided a grid area with a graph background for you to draw a graph of the changes in proportions for each of the phenotypes over time. So for example, if I were doing this, I would chunk this out, so 0, so this is going to be proportion, sorry. So that's going to be proportion, and so this will be approximately 50 or 0.50. This will be 0.25, and this will be 1.0. So if this were me, and of course these are not exactly the way that I would be doing it, but you guys get the idea. What you'd then do is you would take your phenotypes, whatever proportions they were, these proportions surviving, you're going to graph these numbers over time. So whatever numbers you ended up filling in. So if I were to do this for generation, for the very first, they're all going to start at 0.25. That would be times 0 or generation 0. you're going to have generation 1, 2, 3, 4, 5, 6. So after generation 1, our numbers are 0.24, 0.25, 0.28, and 0.23. So 0.24, so this is will have slightly gone down to generation 1. So we'll say that's 0.24. And this is going to be, we'll make it dashed. And you can do different colors for your graph. I'll come back to that in a moment. 0.25, so this next one just stayed on the line. And I'm going to do little dots for that one, just so I can tell them apart. The next one's 0.28, and we'll say that's 0.28 right there. And I'm going to do a squiggly line to that one. And the last one is 0.23, so that one's even lower here. And here we're going to do a solid line. Okay? And so then I would make sure I have a legend saying which of all of these, whatever they represent. So the solid line represented corn. So corn would be a solid line. The one before that was the squiggly line, and that was our P. So we'd have P here, and we'd have a squiggly line. And then one before that was the dotted line, and that's Pinto. So we have Pinto and dots. And the last one is going to be our white, and it was our long dash. Okay, and just so you have a legend, and then you end up plotting those, whatever the next proportions were, you just extend what you've done, and the idea is that you should see some spreading out and some differentiation among these populations. And at that point, we will resume this conversation in lab tomorrow via Zoom, and we'll go over actually determining whether or not there is a statistical difference between these proportions over time.